In this tutorial, we define and explore the properties of quadrilaterals with non-parallel sides using the Desmos geometry tools. A quadrilateral is a closed figure made up of four line segments. This is quadrilateral ABCD. The types of quadrilaterals that we'll be looking at won't have any pair of opposite sides parallel. We'll start with quadrilaterals that have different side lengths. A scalene quadrilateral has four non-congruent sides and non-congruent angles. With a scalene quadrilateral, no pairs of sides are parallel. Now let's look at quadrilaterals with congruent sides. Quadrilaterals with non-parallel sides can have two congruent sides. These are congruent opposite sides. See how sides AD and BC are congruent? Yet there are no parallel sides. Now let's look at a case where the congruent sides are adjacent. Quadrilaterals with non-parallel sides can have two congruent sides. These are congruent adjacent sides. See how sides AD and AB are congruent? Now we look at quadrilaterals with two pairs of adjacent congruent sides. A kite is a quadrilateral with two pairs of congruent adjacent sides. This is kite ABCD. Notice how sides AD and AB are congruent? See how sides CD and BC are congruent. You can see how this quadrilateral has the shape of what you would associate with an actual kite. Here's another way of looking at a kite. A kite is basically two isosceles triangles that share a side. The dashed line helps you see the two isosceles triangles. Recall that isosceles triangles have congruent base angles. This means that a kite has one pair of congruent opposite angles. With this kite, angles B and D are congruent. One other property of isosceles triangles has to do with the altitude. Recall that the altitude of an isosceles triangle is perpendicular to the base. This means that the diagonals of a kite are perpendicular to each other. The diagonals of a kite create two pairs of congruent triangles. See the pair of congruent triangles here and here? This table summarizes the figures we have been exploring in this video and in the previous video. These columns track the number of parallel sides, 0, 1, or 2 pairs of parallel sides. These rows track the number of congruent sides, 0, 1, or 2 pairs of congruent sides. With 0 parallel sides, we saw these types of quadrilaterals. Scalene quadrilaterals have no congruent sides and no sides parallel. With one pair of parallel sides, we have two types of trapezoids, those with no sides congruent and isosceles trapezoids. With two pairs of parallel sides, we have parallelograms, which also have two pairs of congruent sides. The X's indicate that these types of quadrilaterals are not possible. Let's explore quadrilaterals using the Desmos geometry tools. To create a quadrilateral, let's use the polygon tool. Click once and move to a different part of the screen. Click again. Move to a third point. Click again. Move to a fourth point. Click again. Finally, click on the original point. You should see a quadrilateral. Label the quadrilateral. Measure the angles. Measure the side lengths. Manipulate this quadrilateral to verify that the sum of the four angles is 360 degrees. Create quadrilaterals with two congruent sides. Have the congruent sides be opposite sides. Then have the congruent sides be adjacent. Now let's construct a kite. Rather than use the polygon tool, we'll use the properties of isosceles triangles to build the kite. Select New Construction to clear the screen. Start by drawing a horizontal line segment, like the one shown. This will be the horizontal diagonal of the kite. Recall that it is also the base of two isosceles triangles. Let's construct the perpendicular bisector of this segment. Go to the More Tools menu on the side. Select Midpoint. Click on the line segment. See the midpoint? Now construct a perpendicular line through this point. From the More Tools menu, select Perpendicular Line. Click on the segment and then on the midpoint. You'll see a perpendicular line. Use the Point tool to add 2 points to the perpendicular line. Add 1 point above the horizontal segment and 1 below. Now hide the perpendicular line. Click on the vertical line and then press the Hide button. You should now see the 4 points that define the kite. Use the Segment tool to construct the kite. Label the vertices. Measure the opposite angles that share the horizontal diagonal. Measure the side lengths. Try to get your kite to look like this. Verify the properties of the kite. Adjacent sides are congruent. The opposite angles that share the horizontal diagonal are congruent. Resize, then rotate the kite to ensure that these properties are preserved.